So question 10. The particles P and Q of 3 and 5 kilograms are attached to ends of a light, inextensible string over a smooth pulley, held at rest, and then it's released. Find the tension in the string immediately after the particles are released. Okay, we know with this type of question, we deal with each of the particles separately and work out what's going on with them. So we're going to draw separate diagrams because diagrams are good. Separate diagrams for each of the particles, if we can make it draw. There we go. So particle P has the tension vertically upwards and the weight downwards. It's 3 kilograms, so that's 3g. That's the lighter particle, so that would start to move up. So the acceleration would be in that direction. There's particle P. Particle Q, we'll draw that as well. It would also have a tension in the string, and it would also have a weight. Its weight would be 5g. And that particle would start to accelerate down towards the ground. That's all that we need to know. We're now going to use Newton's second law to write down some equations involving this stuff. So particle P, and I'm going to take upwards as being positive for particle P, and I'm going to say that T minus 3g is the mass times the acceleration. T minus 3g equals 3a. Particle Q is going to start accelerating downwards, so I'm going to take downwards as positive to set up my equation for that one. 5g minus t is 5a. That's F equals ma. Okay, there we go. It's a really standard thing at this point, isn't it, to find the acceleration and to find the tension. I know that the question hasn't asked me for it, but it's so straightforward that I think what I'm going to start by doing is I'm going to add those two together, because that will eliminate t. If I add the two equations together, 5g plus minus 3g is 2g, and that's 8a. So 2g is 8a. A is a quarter of g. It didn't ask me for that, but I might need it later, so that it's worth doing it. If I sub that in equation 1, t minus 3g is 5 times a. That gives me an equation in t. T equals 5 over 4g plus 3g. That's, is that 17 over 4? Is that right? And that, have I done that right? 5 over 4 plus 3 gives me 17 over 4 times 9.8 is 41.65. That's not the right answer. What have I done wrong? It's what?
It's 3, not 5.
It's where?
It's 3, not 5.
Oh, it's 3. Of course it is, yeah. Great. Okay. So that's not 17 over 4. That is 15 over 4. And that gives me 15 divided by 4 times 9.8. 36.75 newtons. There we go, for 4 marks. Then the question said, after descending 2.5 meters, Q strikes the plane and is immediately brought to rest. It is given that P does not reach the pulley in the subsequent motion. Find the distance travelled by P between the instant when Q strikes the plane and the instant when the string becomes taut again. I think we need to work out a couple of things here, don't we? We need to work out what the speed of P is at the point when Q strikes the floor. And then we need to work out, then it's just travelling freely under gravity, so we need to do some Suvat stuff with that. Now, from earlier, we've already got the acceleration is 2.45, so this is P until the string goes, until Q hits the ground. P is starting from rest, It has an acceleration of 2.45 meters per second. It's moving a distance of 2.5 meters. And I would quite like to know its speed at the point that Q strikes the ground. So that is what connects those. That's v squared is u squared plus 2as. So v squared is 0 plus 2 times 2.45 times 2.5. Which gives me, oh, that's nice. V squared is 49 over 4. So V is 7 over 2 meters per second at the point where the string would go slack. Now, the string goes slack, everything changes, P starts moving freely under gravity. It has an initial speed of 7 over 2 when the string goes slack. It has an acceleration of minus g, because it's moving freely under gravity. It has a final speed of 0, because I want to know how far it goes before it comes to rest. And I want to know the distance it travels. So using the same equation, 0 is v squared plus 2 times minus 9.8 times s. Sorry, giving me 49 over 4 divided by 2 times 9.8. So S is 5 over 8. What's that? Oh, hang on. S is 0.625. Is that right? So that's the extra height it goes. Find the distance travelled by P. Between the instant when it strikes the plane and when it becomes taut again. So that's how high it would go. It would then reach that maximum height and start dropping back again. And when it reaches the same level again, the string will become taut. And so that's the distance. That's the distance it's going to move. So the distance is 2 times 0.625, which gives me 1.25 meters. Okay, because it goes up, it comes to rest, it falls back down again, and when it's gone that distance back down again, the string becomes taut. That's what we're after. And that's maths.